Hello, Math 8. Welcome to assignment number 3, well, at least the video for assignment number 3, on tree diagrams. So I'm going to teach you how to draw a lovely tree. If you start with the trunk and put some texture in there, and no, I'm just joking. Okay, tree diagrams are not drawing beautiful trees like this, as beautiful as that is. It's actually a mathematical thing. Thank goodness, because I can't draw anything, never mind drawing a lovely tree like this. So let's get right into it. What is a tree diagram? By the way, I'll send you these notes in Teams. If you want to write down these notes, you certainly can. You don't have to. Don't send me these notes back as your homework. Some people are doing that in grade 8 and 9. They're thinking this is the homework, is just writing down these notes. These are just notes for when you're watching the video. The homework assignment I'll give you at the end of this video, okay? All right, so tree diagrams are a method used to list the sample space in a systematic way. Remember, a sample space is all the outcomes. So when you flip a coin, heads and tails. Two items make up the sample space. When you roll a die, 1, 2, 3, 4, 5, 6 makes up the sample space. And sometimes it can be very complicated to figure out what the entire sample space is. So a tree diagram can help you do that. They can also be very helpful solving probability questions. Not so much this year, but when you get to grade 11, 12, we do some, especially in foundations, we do some probability questions, and they can be very difficult questions, and the tree diagram can definitely help you. So, tree diagrams, they're tough. I mean, I don't know, it seems like there's two types of people. Some people just get it right away and it's not a big deal, and then other people struggle with it and struggle with it, including many of my grade 12s. I taught to them grade 8, we did it again a little bit, I think in grade 10, and even this year in grade 12, they're still finding it tough, while other people, no problem at all. So here's a question. Zach has 3 pairs of pants, brown pants, blue pants, and black pants, and he has 2 pairs of shoes, that should say black, so black shoes and brown shoes. And I want to know what's the probability that Zach randomly chooses matching shoes and pants. Now this is completely unrealistic idea here. The thought is that, the lights are off. Zach's not allowed to turn the lights off because his sister's sleeping in the same room or something. And so he has to reach into his drawer and pull out a pair of pants. And he's going to reach into the closet and pull out a pair of shoes. Then he walks out of the dark room and looks and sees, did he get a match? Did he get brown pants and brown shoes? Did he get blue pants and blue shoes, like that? Okay. So what we want to do is we want to list all the possible outcomes for him. And there's different ways you could do it. You could just make a table. You could just list them all. But a tree diagram can actually help you do this. So I'm going to try to teach you how to do a tree diagram. What you do is you start with a dot. It's like our starting point. You can also work downwards. I'm going to work left to right. You can also work downwards, which actually looks more like a tree. I should probably do it that way. But anyway, for whatever reason, I tend to always go left to right. Okay, now here's the mistake that people make all the time. What you have to do is you have to list the possibilities. And people always do this. Like, this is the number one mistake. They go pants, shoes. And that kind of seems sensible, right? Because those are 2 options. What your pants are and what your shoes are. But this is wrong. What you need to do is you need to focus in on one of those 2 things at a time. Either look at the pants first or look at the shoes first. Well, since pants are listed first, I'm going to look at the pants. How many different types of pants are there available to Zach? Three types of pants, brown, blue, and black. So from that dot, we're going to draw 3 lines. And try to make them all end around the same point so it kind of lines up. This one's a little too far probably, but try to make them line up to keep this neat. So now we're going to list our pants. There are brown pants, there are blue pants, and there are black pants. If you want, I've started doing this in recent years because people are having such a problem with these, you might want to even write underneath or up above, pants. This first set of words here has to do with the pants. What's the second set of words going to have to do with? The shoes. Okay, so let's go back to this. Let's say that Zach picked out the brown pair of pants. Then he reaches into the closet and he pulls out a pair of shoes. How many different options are there for shoes? There's the black ones and there's the brown ones. So if he had brown pants, he could then have black shoes or brown shoes. Okay? All right, let's go to this one. What if he'd gotten blue pants out of the drawer, and then he goes to the closet? Which shoes could he have gotten? Well, exactly the same. Black and brown. So again, you go black and brown. And I hope you already figured out what you'll do here. If he'd gotten black pants out of the drawer and then he went to the closet, what type of shoes could he have gotten out? Same thing again, black and brown. So for all three cases, you're going to write black and brown. And this is the end of your tree. You're finished. Now, what does this tell us? Well, let's go through this. I know this is taking a little lot of time, but I want to make sure you understand this. If I look at this one here, put a dot beside this one, what does this mean? This means brown pants and black shoes. Okay, what if I put a dot here? What's this one mean? That means brown pants and brown shoes. Okay, this dot here, what's that refer to? Blue pants, black shoes. How about this one? Blue pants, brown shoes. How about this one? Black pants, black shoes. And what about this one? Black pants, brown shoes. Okay, so notice where you look to see how many different outcomes there are in the sample space. You look at the far side here. You look right here, right? This is where you look. Here's my, don't draw this. Here's my eyeball. And I look here and I see how many things there are there. So the total number of outcomes in this case is how many? There are 6 of them. So total outcomes equals 6. 1, 2, 3, 4, 5, 6. Okay, now what we want to know is what's the probability that Zach randomly chooses matching shoes and pants. So we want to figure out the favorable outcomes. Favorable outcomes. Okay, so is this favorable, this first one? This is brown pants, black shoes. That's not favorable. It's not the same color. How about this one? Brown pants, brown shoes. That's a match. Great. How about this one? The next one right here. Blue pants, black shoes. Nope. How about this one? Blue pants, brown shoes. Nope. How about this one? Black pants, black shoes. Yes, that's a match. And how about the last one? Black pants, brown shoes. No, that's not a match. So favorable outcomes equals 2. Now, you know how to do probability. Probability is equal to favorable outcomes divided by total outcomes. So our probability is 2 out of 6. Of course, you're not going to stop there. You're going to put it in those terms, and you get 1 out of 3 is your answer. Okay? Let's do one more of those. A proud couple finds out that they're going to have triplets. How exciting. What's the probability that all 3 babies are of the same gender? Either they're all boys or they're all girls. Okay, again, here is what you do not do. Okay, start with your dot here. You don't go baby 1, baby 2, baby 3. That's wrong. Okay, again, you want to focus in on one thing at a time. So just picture one of the babies, one of those adorable little babies, and what are the possible outcomes for that baby? Well, it could be a boy or it could be a girl. You're going to have to be really neat here. This is going to get pretty complicated. So this here is the first child. Why don't I set this up? Then you're going to have the second child, and then you're going to have the third child. You're not going to look at all 3 kids at one time. That's what people do, even in grade 12, when they get this wrong. Okay, let's look at the second child. So if your first child's a boy, what could you possibly get for your second child? A boy or a girl. It doesn't change anything. So, boy, girl. Okay, what if your first child was a girl? What could you then get? Yep, it's repetitive. You could get a boy or a girl. So if you only had 2 kids, here's all the possibilities. There's 1, 2, 3, 4 possibilities. But we're going one step further. We're going to the third child. That's okay. Just keep going. So this top one here is when you have the first kid's a boy and the second kid's a boy. What's possible for the third kid if you had a boy and a boy? Well, it's the same. You could either have a boy or a girl. Okay, do I have to keep going through this every time? You know what you're going to do. For each one of these situations, you're going to write boy, girl, because the third child in all these situations could either be a boy or it could be a girl. Boy, girl. Great. So how many outcomes are there total? Remember, to get the total outcomes, we look here. Total number of outcomes, sorry am I writing so bad, is 1, 2, 3, 4, 5, 6, 7, 8. 8 different possibilities. Favorable outcomes, I guess number of favorable outcomes. Okay, what are we interested in here? We're interested in when they're all boys or all girls. Okay, well, let's look at this first dot here. What happened here? We had a boy, and a boy. Hey, that's good. That's good. That's a favorable outcome. They're all boys. How about the next one? Boy, boy, girl. No. Next one. Boy, girl, boy. No. Next one. Boy, girl, girl. No. Next one. Girl, boy, boy. No. Next one. Girl, boy, girl, boy, girl. Nope. Next one. Girl, girl, boy. And finally, I know you all skipped down there because you figured it out. Girl, girl, girl. Yes, this is the only other one that works. These were all no. The bottom one's a yes. The top one's a yes. Favorable outcomes is 2, which means the probability is favorable over total. And once again, we're not going to stop there. 1 out of 4 is our probability that they're all the same gender. Okay, I'm going to give you a pretty small assignment here. Your homework, which is due Friday, April 24th at 2 p.m. It is an attached worksheet, which I will put in the Teams assignments tab. It looks like this. So you're making a tree diagram here. You're making a different tree diagram here, even though it's related to the first one. So you're making 2 tree diagrams, and then there's one already drawn for you, and you're answering some questions. Okay, so that's it. That's the whole homework assignment due on Friday. If you have any questions, of course, let me know. I'm eager to help, and I wish you all well. Take care, be safe, stay healthy.